Yes, hi everyone, this is the tutorial showing you how to make a tank game from scratch in STL2, and you've now got to milestone number 2. You now have a STL window running by this point. By the end of this video you will have, in this milestone, create a controllable tank. The player will be able to move the tank around using 3 different control modes: direct mode, rotational mode and mouse oriented movement. By the end of this episode you will have a tank moving around the screen. So there is a goal. You will set up an STL graphic window, clean up the graphic rendering, handle keyboard and mouse input, load and draw textures. You can draw opaquely, transparently, rotated. Draw a grass tile map, create a single player tank, prevent movement outside the screen window, and measure and limit the frame rate. So, step 1. I will go to my home folder in Linux. I'll create a new folder called Tanx. Go into Tanx, create a new file called Tanx, rename it to CPP. Done that? Click Tanx folder, new file called Tanx CPP. A new folder. Right, first you need the main, first program you need like this. File, save. On mine, I go to Ubuntu. You should already know how to save. Show what's in the folder. Go to my Tanx folder I just created. And I always do this. Keep some instructions at the top to show you how to compile it. This is my full code. I will give you this later on. To compile it on Ubuntu you use this line. Use this line. If you are compiling on Debian or Raspberry Pi, you can use this line. You might have to install STL. You might have to install STL2 on your system before this will work. That will work on Debian. And that one will work on Raspberry Pi. Now save that. File save. Go to Ubuntu. Go to my Tanx folder, cd for the Tanx folder. Copy and paste the Ubuntu line. Copy. Control V to insert it. Compiled. /Tanx to run it. Enter. It runs. You haven't got anything in here yet. Now we need to start creating files. Where do I put it? This is now your basic program, and it compiles and runs, although it doesn't do anything yet. First, create your startup section. Startup, middle, cleanup. So I'm just going to copy this little section into here like this, and I will need ball, void for middle because it doesn't return anything, so it is a void. I always do this: a start section, a middle section, and an end section. Start will always have to return something. Ball returns a ball. It has to have a return. File save. Got my start, middle, and end. Recompile it. Run it. It works, but it doesn't do anything. Got to start, middle, and end. Number 1. First, set up STL windows. So in my startup section, I can copy this bit. This bit sets up your graphics. Hence that sets up the random generator, runs graphics start, which is in my library. Gives this as the window title, this is the size, hardware rate limiting, and whether you want full screen or not. And I will go and get the cleanup code. Here is the cleanup code. So it calls graphics cleanup. It's a routine I've made. Let's save that. But start, got cleanup. Now to make this work, I have to make a copy of my library file, which has only got this in it at the moment. Copy my library file. Put in here. The only thing in the library file is this. It includes the graphics 2D library. Now I will need to include maybe I'll write it. I've got this one. Include graphics H. New text file. Graphics 2D.h. I will also need another file called graphics 2D .cpp. Like that. Graphics 2D.h will include, has to be a hash. Save that. There is a reason why all of these are used. I'll blank these out at the moment because we're not using them yet. This line is include the libraries. This has to be your library path here. I found it only worked if I go /home, /chi, /my home folder, / and the rest of the folders, otherwise it doesn't work. This brings it in. Now, then that will run graphics startup. Library has that in it. The graphics 2d.h has this in it and nothing else, so that. The third file, graphics, it's got to be graphics.d cpp, also has nothing in it. Now we try to run that, but I know it won't work, but there we go. Cannot find rand. Okay. So I think this needs maybe standard IO. Yeah, needs this to make the rand work. Compile. Needs time. So I've got to bring in C time to make the time work. Save it. srand. Might need cmath for that. So I'll use cmath. Save it. Hardware rate limit, full screen. We shall bring in these constants. Some of these will be needed later. / means it's not using this line. We will need these in a little while. I will need hardware frame rate and full screen mode. I'm setting full screen mode to false at the moment because it seems to have buggy on my system. Hardware frame rate on the false at the minute. Save it. This is the file that I'm creating to show you. This is in compiling instructions, constants, start, middle, end, finished. Right, try to compile again. Doesn't work because it hasn't got graphics startup. Right, so I'll go to graphics. I will actually need these routines because startup and cleanup need window mode, full mode, and the other mode. So I'll copy these across into my here graphics.h. Here. I'll copy these routines across. And I'll copy these ones across. I will show you what they do. and I will paste these into here. Now we've got graphic start is here, just copy it as it is. Same as I showed you. In it, get the display mode, which is width and height of the screen, create a window, gets the window size, create to render. It uses the VSync on or off, true or false, to tell it whether it's used accelerated or accelerated and render presync here. VSync is checked here and gives it both if it's requested. Full screen, if it gets to creates the renderer, if full screen's on, then goes to full screen mode. Shows up here. You can have window mode set to 0, gets the window width and height. Full screen mode, gets the window width and height, or full desktop mode, which means windows spread to this full screen. If your system's buggy, you might be able to use this one. This one is buggy on mine for some reason. If it's on, it uses this one. Okay, save that. Must save files before using them. Save this one. Use this one. Save the main file. Here's the main file. Run again. It probably won't work. Yep, because I haven't brought the variables in yet. Now I need to get the variables, which are here. Here are the variables in graphics2d.h. I need the display mode, the window width and height, render. I need these ones at a minimum, which I'll bring into my file here. Don't be using textures yet, but we will soon. So I'm using the display mode, the window width and height and renderer at the moment. Save that. Now try to run this again. Aha. In Windows Club at the moment it's the cleanup. I just don't need fast draw at the moment because I'm not using this section in this bit of code. I will be needing the texture list there. Texture list, number of textures, like that. Now try to run this again. It can't use SDL functions because SDL has not been activated. I'll go here. I have to bring in this one, include SDL, otherwise it doesn't work. It's got to be in the graphics header. In the graphics header, I put that there. So your main one looks like this at the moment. Like this. Library file looks like this. Graphics 2DH looks like this. And the 2D graphics CPP routines look like this. So it's just got to start up, clean up, and change window modes and nothing else. Right, save that. recompile. Still got errors. Does not name. Ah, wait a minute. That's because in here I also need this one. When I store textures, I store a list of textures as an array of T texture, which is a structure, which keeps the texture, the width and the height all together here. So I put them all together. This is in my original code, and I'm just putting it across to the one that I'm writing here. This is the one you should be copying along with. So I've got text SGL, brings an SGL here, stores the textures in a structure, has the variables render mode, window, renderer, list of textures. Probably not going to use that bit. Right, run again. Aha. It's got in here fast draw net. I'm not using fast draw, so I can delete that. Right. It works. So what you've got so far, this is what you've got so far. We're only using hardware frame limit, full screen here. Here's the compile instructions. Here's your startup. Just copy it exactly as it is. Middle, clean up. So we are starting the graphics with the window title, the size, hardware rate, frame limit, full screen. Cleaning up here. So all of this is done. All of that, which was a lot, was to get the graphics set up and the graphic cleanup and nothing else. This is what the graphics library looks like at the moment. Stores textures, stores the information we need, start and close routines, that's it. And they are here like this right now. And I don't need this bit because I won't be using it. Right, run that. Compiled. If I run it, oh, I have a window, but nothing happens. That was step one. So now we have started the graphics, which goes to start graphics here, which goes to start graphics here, start SDL, get the display mode, width and height, create the window here, get the window size, create the renderer here with the VSync if we want it, start full screen mode if we want it, does the middle, nothing, does the cleanup graphics here, cleanup graphics is here, the full screen if we want it is here. Cleanup destroys all the textures. For every texture, destroys every texture in the list, in the array that's being used. Destroy the render, destroy the window, create STL. That's what we've got so far. From our tutorial, set up STL graphics window, clean up graphics rendering. Step 1, set up the graphic window. Before we can do anything, we need to a window and renderer. is initialized using graphics startup, using graphics 2D CPP. Create STL, so the STL in it. Create window like this. Create renderer like this. Start the graphic, call from startup. Call from a startup routine here. Calls graphic startup. The result 1024 by 768 game window STL renderer ready for drawing. And what I'll probably do in the middle, although we won't be using all this yet, here is in the middle, because it's not doing anything, I'll just go while running. This just keeps looping, and I think I might need a variable for this. Grun variable has to be true. I have to have that, so I'll go get that. Might as well just copy all these variables because I'm going to need them soon. It's this one, grun is true. These are not used yet, but they will be used soon. So we are just getting the graphic rendering working first. // just removes the line because we don't need it yet. We will need it. Save it. We've got the running. Now, if we run this now, and we run it, window, no way of getting out. Number one, we've got a window. Now, we got a window, it's still render, ready for drawing. Clean up graphics. Only release resources when the game exits. Okay, this graphics clean up. Destroy the textures. We'll be creating textures soon. Destroy the renderer. Destroy the window. Shut down STL. All called in the cleanup routine that I showed you. This prevents memory leaks. So now we have a program that works. Tanx, compile it, run it. It doesn't give me a window because I get Ubuntu error sometimes. So I've got to go in here, PowerShell, reset Ubuntu like that, WSL shutdown to reset Ubuntu like that. And then rerun Ubuntu. We've now got a window that works. Now we are setting up keyboard and mouse input. Now we've got nothing in the main at the moment. I'll create two routines, process and render inside the main. Like that. And inside the process, oh wait, in the render, I'll do the render one. So don't worry, you'll get all of this code by the end of this you'll have the entire thing of this. I'll show you the whole thing. Render, we have clear, map, tanks, none of these are all written yet, but what we're interested in is this one, clear and flip. Clear and flip are the two we're interested in here. Render. Some of these are used later, they're not used yet. Clear and flip. So I'll grab the flip routine here. Flip. So middle, it will loop until exit. Process here, which is nothing at the minute. Render, which is here, and it does a clear and it does a flip. So it clears it to black, then it flips it to the screen, and then it loops again. It should do that continuously, and it should work. Should give me graphic output. Oh, yeah, give me graphic output, but nothing else will work at the moment. Now, next is keyboard and mouse input. We need player controls, inputs processed inside. There is a reason why I'm doing keyboard input first. Graphics I've done, window I've done first. Keyboard is now next. So it was like number one, sub-STL graphic window, done that. 2, clean up graphics, we've done that. Number 3, set up keyboard and mouse input. So we are doing that now. So we've got the graphics, because now we've at least got something drawn on the screen. Now in the process, I need this one, process user input here. Copy this one into here. You need this in your file here. So I'm just going to go and get a copy of it. Oh, it's a process user input. Get the STL event, poll the events. This is mouse, keyboard, keyboard, mouse, the little close button up here, and all the other STL events. Quit if running, then running is false. If they push a key and then a key down and it gets the code, escape and we exit, running is false and we exit. Changes the movement modes. If they push 1, 2 or 3 on the keyboard, change movement mode 1, 2 or 3. They push up, down, left or right, changes key up, key down, left, right. If we want display keys on, we'll draw the key here, key up, and then WSAD turns key up, down, left, right to off. If they push the mouse button left, is mouse left on, mouse right on. Mouse up, left off, or right off on the mouse, and if the mouse moves, then we get the mouse state, mouse X, Y. So I'll go get these variables now. That is all of these ones: keyboard, mouse. Is there anything else I needed? I think there was. I think it was probably display keys, and I don't need that one. Display keys we need as well to make this work. Try again. Oh, mouse movement variable, I need to put that in there. And that one is, we need this one here. Right, compile, it worked. Run it, it works. Now, you can't see it, but if you push up, down, left, right, and mouse, and move the mouse, it stores that for us. And if I push this close, it goes out. And if I push escape, it now goes out. All keyboard now works. Hope you can see how this works. These are just needed as backup support. This is bringing my library. Here's your install instructions. The constants we're using, ones we're not using are dashed out at the moment, commented out. All the variables. This loan textures we haven't done this yet. This is keyboard. Start up. Process keyboard input, user input. Process does user input only at the moment. Rendering just clears and draws. Oh, this just clears. This just draws. Render just clears and draws at the moment. Middle, all that does is loops and goes process render. Clean up, exit. That's it. Nothing else. Right, so now we have keyboard input as well. So we go on to the next step. The next step is so keyboard and mouse. We need player controls, inputs, process, including process user input. So keyboard presses. When a key is pressed, it creates STL key down, like this. Movement keys are WSAD. Stored as key up, down, left, right. It's key released. When the key is released, it's STL key up, and it makes it false like this. Change the movement modes. If we push 1, 2, or 3, it changes the movement modes. So it switches to movement mode 1, 2, and 3 like this. Stores it here. Mouse input. If it moves, it stores the mouse state. If they push the button, it stores the states here. Left or right mouse. This will later be used for aiming and shooting. Next, load the textures. Textures give visual appearance to the game objects. They're loaded in load textures. So we'll do that. Here is our program. And in the startup, we shall load textures here. Just grab the load textures bit here. You want to make your file exactly the same as this one. Load the textures. You're going to need some files. Tile grass, tank body, tank turret. I'll show you these in 1 second. So we've got the load textures routine. We need to have load texture bitmap and load texture bitmap transparent in our library now to make this work. So this is the full library file that I've got. I need these two. In here, and I need these two routines here. Just copy these, type them in. Let's load the texture. It creates a texture, STL texture, and load uses STL load bitmap to load the texture. Then it creates a texture from the surface and stores it in the array. If it fails, it errors and it returns -1. Because if it works, it will return index in the list. This int is the index in the list. Is this opaque? So blend mode none on this one. Gets the width and the height and stores it in the structure. Freeze texture, moves the counter and returns the index. So the first loaded bitmap will be index 0. Transparent is exactly the same, loads a bitmap, but it uses whatever transparent color is given here, it's used as the transparent color. Set color key makes the one color on the surface transparent. And when we've got a list of textures here, which is of this structure here, texture width height, stored in here. So every time you add a texture, it will go number 0 in this array will be the first texture, 1 will be the second texture, 2 will be this next texture, and if textures remembers how many there are. Now at the end of the program, it does a loop 0 to all of the textures, destroy the texture in that array, in that structure to remove them, and destroys when it destroys the window, like that. Now you will have a problem because you don't have these image files, but I will just show you something in here. This is the grass tile. This is 32 by 32. Just create a 32 by 32 image. Save it as tile_grass.bitmap. And just draw a little grass. 32, 32. Just draw something. And save it with the files. The other one is, this is tank body. Tank body.bitmap, 64 by 64. You can either just copy the screen, copy the screen, 64, 64, draw a little tank body like that. Always make this magenta, which is here, 255, and this number 255, because this is the transparent color. Anything that's 255, 0, 255, this color will become transparent in the game. This is transparent. The reason we do this is because this bit, we don't want this drawn, we want this transparent. That's the tank body. And the next part is the tank turret. All of these should be obvious. This is 64 by 64. Copy the screen, draw your own little tank turret. Yep. Just draw you and save in a file tankturret.bitmap here. Right, done that. I will upload these files at some point and then everyone can have them. Next, what are we doing next? Now, I might even have a problem now. 1 second, because I haven't got the files either. I've got to go get the files. I'm just going to copy them. 1, 2, 3. Copied. I'm just putting them into my main folder. And I am, usually I have a folder in here called images. But you can't, as long as the folder path is the same, it will work. Paste them in that folder called images. But as long as you've got the folder file name here, images is the folder in the same folder as this one. As long as these match, this will work. Now just save this and try this. See if it works. Oh, I have not got grass tile, tank body or turret variables. I've got to bring these variables, copy them into my program, which are here in the text. So now these store indexes, and then when it's closed, these are automatically destroyed by the engine. Run it, and it worked. There was no error saying that it didn't load the bitmaps, so this worked. Next, texture give visual appearance to objects. Textures are loaded in using load textures routine. Load textures here is loaded. Textures are loaded here. Grass is not transparent and uses load texture bitmap. Body and turret are transparent, so they're load texture bitmap transparent and use 250 which is magenta in this one. Grass tile loaded like this, tank body is loaded like this, turret is loaded like this. Why use transparency? Magenta becomes invisible. This removes background around the tank image. Next, draw grass tiles for background. Purpose, create a simple battlefield, and it's in render map, which I shall do now. Now in our rendering here, we want render map. So I'll go get this code. All of this is fully functioning and all works. This is the code for render map. So I will put it here. And this bit here. Clear render map flip and repeats this loop. Oh, we need the screen width and screen height, and we need the draw texture routine. Yeah, these routines in the graphic library now. So I think we need these we don't want to copy across. There. And we need these here, which I'm going to copy across. Into the graphics CPP. that. Save it. Save all of it. Oh wait, no, wait a minute. We need drawing functions. I'll just grab draw alpha and rotate here. These graphic drawing routines here I'm going to grab. And put them in here into my library. And over here draw texture, draw alpha and draw texture. Says the alpha mod. I didn't bother turning this to full alpha, 255 full alpha, because I think it's already full alpha. Set up destination rectangle and then just copy render copy. Alpha set texture alpha mod here for the texture with the alpha value, give it the alpha value, and because the blend mode is on, it draws it alpha blended. And rotate texture, you give it an angle, sets the alpha mod. I'm just doing it to no alpha, and then use render copy EX because you can give it an angle here. So that's what this one does. So I'm just going to copy this across and copy it into my CPP. So you just copy this exactly how they are. Now right, let's try to run this now. Compile. Oh look what we got. We got grass. Because I'll just show you how that works. In the Tanx render map here, clear render map, flip like this. Screen X is 0. The number of tiles is the screen width divided by 32 for how many tiles. SX, SY and SX is where it's actually drawn the screen. Then it will, while go up, this bit does the row, the left of the row, clicks forward by 1 and it increases the SX by 32, so it moves across one full tile and then draws SX, SY is the exact tile coordinates. So 0, XY 0, 0 will be drawn 0, 0, but then XY 1, 0 will be drawn at 32, 0. Because whereas X clicks 1, SX clicks 32. It gets to the end of the row, did, then it'll go down 1, Y will go down 1, SY will go down 32, so it moves down a full time, keeps going till it's done the whole screen. And it uses draw texture. Here, texture grass is an index number of 0, I think here, because when you are over here, index then gets the texture structure, a pointer to the texture structure, gets the texture structure, a pointer to it, use that to get the width here from the texture structure and the height for the texture structure here, and the texture from the texture structure here. So it's got, in here, it's got all the information it needs. You don't need to give it a width and a height. So that's all done. Now it's got drawing. Draws grass tile background here for a simple battlefield. Tile drawing loop is like here, like I just explained. Each tile is 32 by 32 big. Loop fills the entire screen like this. Complete tiled background. Now, create the player tank. Game currently contains one tank controlled by the player. Setup function, setup player. Now, we have grass background and keyboard input, but no tank, so we get the tank. Go here, go to variables. I now need, the player needs an X, a Y, an angle, and a turret angle. Here. Start, we'll need to set up to play a tank here. Set up player for this bit here. And set up the player. So now the tank starts 100, and the angles are 0 and 0 for the body angle and the turret angle on the tank, so they're two separate. Save that. Next will be drawing the tank. So just find that. Drawing the tank is here. This is drawing the tank. And also copy this here. So I need this in here. So it clears, draws a map, draws a tank, then flips. We've got the draw tank routine here. It uses a rotate draw to draw the tank body at player XY. XY is the center of the square. The XY of the square is at the center. The player XY is at the center, and it rotates around the center at player angle for the body. Then it draws the turret, takes your tank turret, rotates around the player center with the turret angle. You can draw a cross at the middle center if you want, here, and you can draw a rectangle around the whole player here if you want. But at the moment we'll save that, actually save all of it, run it again, and that should create a tank. There we go, got a tank. Set up player, set it up at 100, set up player angles and turret angle to 0, render tank. It's all inside render tank, and it rotates, rotate, draw the body, rotate, draw the turret. Result: tank body rotates independently, tank turret rotates independently, just like a real tank. Step 7. Direct movement mode. Oh yes, we've got several movement modes now, which is this routine, which is, you know, a bit big. Straight after the user input, we will then go that one, just one sec, grab, process, tank. like that. So it processes user input, gets mouse keyboard and the escape button in the corner, and processes the tank. So if you've pushed up, down, left, right, or moved the mouse, it then updates the tank, like this routine here. Process tank float time. We're going to be using a float time. At the moment we don't have a float time, but we will be using a float time. Like that. It's not being used at the moment. It's how many seconds, how much time has passed between the last frame and this frame, the start of the last frame and the start of this frame, how much time has passed between that point and that point in seconds. So it's a fraction of a second. So if this says 1, it means 1 full second has passed. And now the tank is moved times by how much time has elapsed. This stops the frame rate from going wrong. It means the movement's always smooth no matter what. Now first movement mode is direct. If they push up, it goes up by the player's speed times by the time in seconds. So 1 second is a full player speed move. And I'll just go and make sure that we have got up here. Rotation speed is in seconds. Angle, no, this is pixels per second for the X and the Y. Rotation speed is 90 degrees per second. It rotates. If they push up, down, left or right, the X, if they push up or down, Y goes minus if they push up, or goes plus if they go down. Plus, minus equals means take this number away from this one and store it. Plus equals is add the number to that one and store it. Left and right is the same. X minus X is left, plus X is right. Up, down, left, right. And now we do some magic here. Up and down is it's minus 1 if it's left, 0 if it's in the middle, or plus 1 if it's right. If key is up, up, down, minus 1 up, 0 in the middle, and plus 1 down. If they push up, then it's minus 1 here. If they push the key down, it's plus 1 down here. Now left, right will be minus 1 here, 0 in the middle, and plus 1 on the right. If they push left, it's minus 1. And if they push right, then it's a plus 1. Now if they push left and right at the same time, then it goes 0 in the middle because it's balanced. Now what it does, wait a minute, is it here, where is it? Player angle is a degree, in degrees, 0 being up. Uses the angle array, which is here, which is an array, a 3 by 3 array. If this one is up left, if it's up left it uses this one. If it's up it uses this one, 0 degrees. If it's up right it uses this one, 45 degrees. If it's right it uses this one, 270. I don't know if this is right. This is up left, this is up, this one's up right, this one is left, 0 is in the middle, 90 degrees is to the right. It sets the up, down, left or right position to the angle, puts the angle in player angle here, so it moves to the right angle. The turret angle is then calculated from calculates the angle between an XY player position and mouse position X and Y in rads, then converts it to degrees. So I'm going to have to grab this routine here. Rads to degrees. So if you want to like copy that bit, Try and like copy these. This is degrees to rads, rads to degrees. Calculate angle. Calculate the angle from A to AXYA to XYB in rads. Angle to offset X and Y gives you rads. Give it an angle in rads and it gives you an X offset or a Y offset. Yep, this aims the turret towards the mouse. Rotation movement is whatever the angle is, uses angle to offset X and Y to find the direction, turns it to rads, gets the angle, turns it to rads, gets the offset X, times it by the speed. So if they're going this way, it'll go that direction, like that. Times by the speed, times by time is the variable factor. So if they push up and the angle is up here, it'll go up. If they push down the angle, it'll go minus the number down. Left rotates left by rotation speed. Right rotates right by the rotation speed. Always aims the turret at the mouse. And the third one, movement. Key up means at player angle is towards the mouse. Key down minus plus is towards the mouse. Minus is away from the mouse. Player angle minus is so it goes up or down based on towards or away from where the mouse cursor is. Left and right. I will now create a new angle here, which is a player angle 90 degrees to the right. Now if they push left, it's that angle, the offset, using that angle, the offset to the left of them. And then using that angle, they push right to the right of them. Turret is always towards the mouse. The body is always towards the mouse. Break. Cases, you have case 1, gets the end of a case, has to have a break here, otherwise it will bleed into the next section. It depends on the movement mode here, you see. We create the variables here, constant don't change, up, down, in, got to be created, float angle we're using here. Break here, case 2 rotational, break here. Case 3 mouse movement, break here. And this bit isn't used yet, but it will be. So we've got that bit. Right, now let's have a look. Oh, it works. Left, right, up, down, or movement mode 1. Push 2, movement mode 2, up, down, left, right. Movement mode 3, always aims towards the mouse. Forward, backward, right, left. This is because the frame time is not set up correctly yet. And there's no frame limiting either. Wait, I can make the number a bit better. Here I just turn it as a 0.01 because I thought it'd be small enough. I'll go 0.001 of a second and see what that gives us. Might be a bit better. Oh, there you go. You will notice we can walk off the edges and disappear. So we've got the movement, got the tank. You also notice it rotates beautifully and draws beautifully. There we go. Right. Next. Direct movement, classic top-down movement. WSAD, example, flare y plus minus plus b times time. Movement is frame rate independent because it uses time. Tank facing direction, tank angle, uses angle array. Automatically points the tank towards the movement direction, as in angle, turns it like this. Up is 0, right is 90, down is 180, left is 270, like what it says here. Turret aiming. Turret always points towards the mouse, like this, shown here. Rotational movement mode simulates tank steering, is enabled with number 2. A turns left, D turns right. Player angle is rotation speed times time. Move forward with W. Uses trigonometry, sin and cos, which is, to show you, here, look at these routines. This is degrees to rads, rads to degrees. So it turns rads, which is up to 2 pi, pi times 2, and turns it into 0 to 360. Rads degrees does the other way. Calculate you used to use atan. This was the easiest way of getting an AB, AXYA to XYB, was to use atan. And I had to do this weird math here, going y minus bx minus ax, and the other one it had to be flipped around the other way because it's negative. So I had to use ay minus by here because it was negative, it's inverted. But essentially it uses what it says here, sin and cos, to make this work. But this, I'm just giving you the code that already works, right? So I've already done it. It wasn't that easy. And then to convert the other way was angle to offset x, uses sin here, and the y one uses cos here, like that. Tank move backward, moves opposite, it feels much closer to a real tank. Yup. Mouse movement mode, twin stick shooter style, enable with that number 3 key. This is the reason why we have got here SDL key 1, 2 and 3, movement mode 1, 2 and 3 here, because it changes the movement mode to 1, 2 or 3. And then when we get here, it's got a movement mode in a switch statement here. This is in process tank, movement mode in switch statement here. Forward and backward, W and S. Strafe left and right, A and D. Yes, it's not realistic, but I'm just showing you how the movement modes work, because this is more or less the same for every kind of top-down game, and really applies to like side-on games. It could apply as well. So just showing you the principles, this is how it works. You probably wouldn't use number 3, but it's there anyway. Computer uses player angle plus 90 degrees. This creates a strafing movement. Tank follows the mouse. WASD moves freely. Feels like modern action games. Yep, exactly. Right, so now we have, yeah, you know, it's just set slowly, but you get the picture. We've now got movement, all looks and works great. Limit movement to window borders. Prevent tank from leaving the screen. Location at the end of process tanks. Here. Yep, so basically that is this bit here. This bit here. If player X is less than 0, It's not naught because it's the X and Y is the center of the tank. That would mean half the tank would be off the screen, half the tank would be on the screen. That's why I'll go plus 32. So the center is closer than 32 to the border, then it's put to 32 from the border. And if it's the window width minus 32, then it's clamped to that number. So if it goes to the edge, it'll clamp to naught. If it goes to the right, it's clamped to the window edge. It's clamped, goes to the top, it's clamped to the top, goes to the bottom, clamped to the top, bottom. So it's clamps it to the four borders. Now I've done that. If I save this, I recompile. Now, look, clamps to the borders. You must always test everything. Every time you change anything, always do a recompile because you don't know if your code gets broken. It works. You really notice here there was no error. Well, here is an error. Every time you change something, always recompile. Go back to the tutorial here. Left border, right border works like this. The bottom border matches half the tank's sprite size. This keeps the entire tank visible. Yeah, the entire tank stays visible. Next is the frame rate timer. Well, hopefully you should be getting, it should hopefully have each section working as we go along here. You can pause the video anytime. At the end I will run through the full code of the complete one, which is all working and fully functioning, so you can just literally just write it all down, copy it all. Okay. Next is the frame rate timer. Purpose: measure frame rate timers and frame rate, frames per second. Starting, set up frame rate timer. So I'll just go grab that code. Here is our frame rate code. I'm just going to copy it across. Like this. Start set up frame rate timer. At the beginning it says a G last counter. Get performance counter is a very high frame rate tick counter. It has many ticks per second, thousands I think. And all this does is gets whatever number that counter is at the time. So it'll go tick, 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 so it just grabs whatever's on that counter. Current second, it takes the counter, divides it by what a whole second is to get the number of seconds. So we now know we're on second number 5, for example. That divided by that is 5 point something. So we're now on second 5. Last second is whatever the current second was before. So every cycle it checks to see what, like, last second is. You just put last second to the same as current second at the beginning, so they're both the same. And as soon as it changes between last new second is different to the last second, and it changes, now we know we're on a new second, and it activates process second here. Last frame time is however long it took between one frame tick to the next frame tick is what last frame time is, and it is in seconds. Null frames is reset at the beginning of every second, and every frame will go tick 1 frame, tick 2 frames, tick 3 frames, tick 4 frames. When it hits the second, the frames per second is then stored, and then those frames gets reset to 0. Now every tick, every time it runs a cycle, gets the current counter, whatever tick we're on, gets the current second, calculates the current second. So we're on second 5. Now it's calculated, we're now on second 6. Now if we're on 6 and it was 5, now process the second routine here, only at the second boundary. Then makes last equal to now, second, last second equal to now second, so these are the same. So now it'll ignore this, it'll keep going until it changes. Stores the frames per second here, resets the frame counter here. If displayed frames per second, then we will print this line once per second. Frames per second as an integer, hash int is integer, we print f. Frame time, hash f is a float, 2 is how many places, and if you go dot, it means dot 2 means with 2 decimal places float. And milliseconds, oh, I don't know if it's milliseconds, oh, that might be wrong. Frames per second, how many frames per second? Frame time is in seconds, I think. It's in seconds, I think. And it prints it. I'm going to need this display per second thing, aren't I? In my code. Also need these. We'll need these variables. And I will need the frames per second timer. Oh, I will also probably need the hot software limit frame rate as well. So we need all of these. Oh, where were we? We was here. Process the second. Gets the last frame time is the last counter minus the current counter divided by seconds. It has to become a float, typed as a float to make this work, because it might end up being an int otherwise, and an int you'll just get the number 0 come out. So you have to tell it you want it as a float, typecast float. Last frame time is a float. Last counter equals current counter, so it remembers it. Whatever this tick here, we will get a tick, mark the time, do all the calculations, and then remember that for later. Increases the frames with a frame rate timer. So don't worry if you miss anything. I'm going to scan over the entire code of the complete one when I finish. Like literally, this is the complete code of the finished one. Once I get to the end of this video, I will scan over all of these, the proper working code, and you can just literally just copy it. So float target time, target frame rate, this is in seconds. 1 divided by 60 frames, 1 second divided by 6 frames. It does, wait a minute, I need to do something. Set up frame rate timer here. Set up the frame rate timer. In Startup, set up the frame rate timer, which is here. It clicks the first tick, marks the time, marks what second we're on, resets frames to 0, resets the frame time to 0, marks the time, marks the first second. Alright, save it. Does the frame tick, marks the time, checks if it's right past the second boundary, remembers the frame rate, frames per second, writes the frames per second to screen if you wish, which I shall now turn on, just to show you what that looks like. True, just to show you what that looks like. process it using the frames per second. Now last frame time. Now it will be accurate. Render. If this calculates last frame time for us. So this is always out. This tick calculates this for us. Now if we wish, we can do software limit frame rate. Current counter up. We can mark a time at the beginning of the frame. Once it's processed and rendered, we mark a time at the end of the processing and rendering. Process and render, mark the time. It's not actually finished yet as such. Now it marks the time. Now, last frame time calculates how long it took to get from the start of the frame to the finished processing. That is last frame time. If last frame time is less than the amount of time we want, do a delay for that many milliseconds. So we start here, we process for half a millisecond here, but we really want 5 milliseconds. 10 milliseconds is the actual thing, so now we go delay, and then we get to end here. This is only if this is on. If software limiting is off and hardware limit is off, it will run at full speed, as many frames per second as possible. If this is on, it will use SDL delay to render after each draw. I don't know if this is a good idea or not. I think it's sufficient using delay, because I think a delay actually releases the processor while it's delaying. I'm not sure. The other option is in here, graphics startup. You give it a VSync hardware frame limit, and here if it's a VSync on, it'll be accelerated and render present VSync, which means the graphics card and the hardware waits for a VSync before it draws. I think it uses the render present, waits until it can draw. You can turn this one on, or you can turn this one on. I don't know if it's a good idea to do both. Maybe it don't matter. Don't know. But they both work. So, and now that is done. So let's try it. Save it. Compile OK. Run perfectly. And there we go. If we now have, and we limit our borders, we've got somewhat of distance towards a proper game. Now this is basically the basis of everything else you can be doing. I've just done it on one screen. Later you will have more. And here we've got frames per second 62, 15.5. This is using, find out in a minute. Software frame limiting. So I shall change that to hardware frame limiting. Recompile. Done. Hardware frame limiting. I don't think you can really see any difference. I did find just one problem with this though, where you can see the numbers are more or less the same. I did find one problem with this though, on my one. If I do full screen equals true, and I'm not quite sure why it does this. I think it gets juddery like this. This is not overdrawing. This is not because it's drawing too much. It's just because it's in full screen mode in WSL, I think. It's actually rendering at a very fast frame rate, because if you quit, it's not the frame rate. I think it's an inefficiency with WSL on this system, on WSL. So I tend not to use that full screen at the moment. If you compile properly in C for actual Windows, you shouldn't have this problem. But yeah, I've got that. So you've got a full complete thing now. I'm just going to show you all of the code from start to finish. This is the complete, well, this is the code that we've just been stepping through. So just type it all out, pause the video. That's the main Tanx CPP one. Hold on a minute. Now we've got the library file w.h, graphic2d.h. The first file was tank.cp, what we want to call it, library.h. Next, graphic2d.h. includes STL texture, no, T texture. I created this. Oh, this one is literally just that. That's this is all that I've just wrote out, and this is literally the minimum code that you need to make this bit work now for this section. So I hope you enjoyed, and I hope that you've got this. If you've got this far and you have fully completed this, these are the two compile strings that should work on Ubuntu and Debian. Debian will work on Raspberry Pi, and Ubuntu worked on mine. I was using Windows 11 WSL layout. There is another thing. What was it? Aha, here we go. There was a string that could work on x86 min at GW on the Windows SL layer, but I haven't got this one working yet. There are other options. This is the compile string, the library include string that I used. It has to be from the root on Linux. This was somewhat difficult to get working. Yep, I hope you enjoyed, and by now I hope that you have a fully working prototype, because I just think this game's absolutely awesome, and I'm just going to carry on going with this thing. So it's like I'm going to keep going. I have built this game so many times. I can make this game easily, so easily that I will literally show you how to make it from start to finish, step by step, all the way through. I will show you how to make it. Once I've got to the end, then I will do depth. I'll carry on going, more detail, depth, perspective, and have a go at doing 3D. That by the time I finish this, and I'm going to try to do networking in networking in C++ from scratch, hopefully from scratch, or at least get networking working. So this is actually fully working, full complete game, and in the end fully completely polished, finished, and then posted up on my website on the internet, maybe published as a full game. So I hope you enjoyed. I hope you liked the video. If you got any suggestions, ideas, comments, anything, send them across, email me, whatever. And this one was tank movement. This is milestone 3. There are actually 10 milestones. When I can finally find the document somewhere. There are actually 10 milestones. Compile hello world, 2 STL window, 3 look here. Player movement, STL window, graphics, keyboard, mouse, load texture, draw grass, single player is a tank, 3 movement modes, direct movement, rotation movement, mouse movement, limit movement to a window border, and frame rate. Okay, it's quite a bit. That was number 3, just to make that bit work. 4, projectiles, explosions, particles, muzzle flash, hit detection. Then you'll have 4 tanks being able to shoot each other and explode. So this will be more or less a little working little game with 4 tanks. Number 5, tile map. For this I will need a map editor. This is going to be a lot of fun. Not really, but yeah, it will when it's finished. It will need a map editor. Map and map editor. 6, bases, flags, pickups, mines, turrets. The reason why I'm doing mines and turrets here is because the other tanks don't shoot at you yet. Here we've literally got a game going. It's a tile map. You can drive about. Walls stop you from moving. You can blow walls up. Here you'll have flags, bases, turrets, mines. Reason why I've done turrets and mines here is because you can get blown up. Because number 7 will be bot AI, tank bot AI for a 1-player game. And I'd rather have the turrets and mines ready for when you do the bots. 8, set up the full game, limits, and actually set up the full game. 9, set up game screens. Main menu option, you can do this at the beginning or you can do this at the end. At the moment I'm doing it at the end, but I would probably, when I make my own games, try to set this up at the beginning. It can make your code a bit more complicated, so do it at the end at the moment. And then 9, music sound. 10, cheats, other game types, and then we can just go like all sorts of other things can be added after this. But I would say after number 10, that's complete. It's complete. So there we go. We're literally gonna make an entire game on YouTube for free. So just follow along if you like this show. Yep, thank you very much. Hope you enjoyed. I hope you've managed to do this, and I will see you in the next one.